day, everyone. Today we are going to be looking at independent events in probability. You have dependent event and you have independent event. Now, independent events are those events that one can occur without necessarily affecting the occurrence of the second. So the occurrence of the first does not affect the occurrence of the second. So it means that the both events are independent. Now we have an example on the board here. We have in a school of 100 students, 40 were randomly put in a Monday physics class independent of that event. 30 students were put in Tuesday chemistry class randomly. If a student chosen at random is in physics class, what is the probability that he or she is also in chemistry class? Now, if you look carefully, you discover that this is a conditional probability. So you can have a conditional probability that is independent, and you can also have a conditional probability that is dependent. So for this conditional probability, it is an independent kind of conditional probability. So we have something like this. Look at what they gave us. What is the probability that he or she is also in chemistry? So they give us what is the probability of chemistry given physics. So I'll say let my P of this be the probability of physics, the probability of physics, and this be the probability of chemistry. Good. Now the question now says we are to look for the probability of chemistry given that the person was taken from physics. You see that? So the probability that is, what is the probability that he or she is also in chemistry? So the person is taken from physics, then from that physics, now what the probability that is in chemistry? Now if you make a conditional probability, you know this is going to give me C intersection P all over the probability of P. This formula is necessary. Now I have probability of P is equal to, here's the probability of chemistry. Look here carefully now. I have 40 were randomly put in Monday physics. So we have 40 for physics. So probability of this is going to be 40 over 100, which will give me 2 over 5. Then for chemistry, I have 30 students were put in Tuesday chemistry class. So this is going to be 30 over 100, which is 3 over 10. Good. Then the probability of multiplication, this intersection this, is going to give me the probability of C multiplied by the probability of P. I'm doing this because this is an independent event. So since it is an independent event, the occurrence of C, the probability of C, does not affect the occurrence of the probability of P. You see, so that's why I'm putting my multiplication. But if it was not independent, if it was a dependent, it wouldn't be this kind of multiplication. I would have gotten something else. So because it is independent, I have this. So probability of C, which is 3 over 10, multiplied by the probability of P, which is 2 over 5, which will give me 3 over 25. That's the probability of this. So coming back to my real question now, it's asking me for the probability of C given that P had already occurred. It's going to be this, which is what I have here. So I'm putting it 3 over 25 divided by probability of P. And what's the probability of P? 2 over 5. 2 over 5. So this is 3 over 25 times 5 over 2, which is going to give me 3 over 10. 3 over 10. So that's how it is. When it comes to independent event, one occurrence does not affect the occurrence of the other event. So if you have any question to ask, you can do that on the comment section. Please like, subscribe, and share this video so you'll be among those that receive all my videos that will be coming out. Till then, see you in the next class.